Good morning, everyone. We won't have a Microsoft Teams meeting today, and so I thought I'd just record a quick introduction to today's lesson. And so you'll see this one on Compass. Today's goal is going to be about the life cycle of stars. We did spend the last lesson really finishing off that one about the sun, and now we're moving on to look about all stars like our sun. What's their life cycle? What happens to them? How are they created? And what happens to them as they age? What do we know about that? And so, at the end of today's lesson, I want you to be able to describe how stars form and describe what happens to small stars and large stars, because different things happen when they die. So, moving into the style lesson, it starts off with just this little animation to begin with, and so you can click and drag it around, and you might recognize the Southern Cross is just in that bright bit there. And this is like this is an amazing image. That it's pretty hard to get these really obvious dark patches which you see in the Milky Way. But yeah, this is the Milky Way stretching. You can kind of see that lots of Aboriginal cultures saw this as like being the head of an emu, or the whole body of an emu, and so this is the emu's head and this is the emu's body, and it continues on. But pretty hard to see unless it's a really dark night and you're in a really dark area. Anyway, worth having an explore with this one. See if you can find any other stars or constellations that you recognize. Then, if I can move this down. And so after you've had a bit of a look at that, we'll move on to the next area. I'm talking about how are stars created. And so the woman here is saying that stars appear static and unchanging in the night sky. Static basically means unchanging. But new stars are being born all the time, and after millions or billions of years of shining bright, they eventually die. So first question, how are they born? It says stars are formed in vast clouds of dust and gas called nebulas, or nebulae. Most of the gas in a nebula is hydrogen, the lightest chemical element. Many nebulas are so big that they can have millions of stars at different stages of formation at the same time. Star formation begins when hydrogen gas is pulled into a dense ball by gravity. Before it begins producing heat and light, this ball of gas is known as a protostar. And you might have seen these pictures, like especially that one. This is a pretty famous one called the Pillars of Creation. But these are nebulas. This one it says here is 15,000 light years away, which in the scheme of things isn't that far. And then there's a short clip for you to watch about how stars form and the conditions that they form under. And this is a important one, like, can we put the right words, 1, 2, 3, 4, 5, 6, 7, 8, into those 8 gaps, 8 blanks. This big idea, after a star's become, has started fusing and started releasing light and heat, that we call it a main sequence star. It says here, the sun has been in this stable state for about 4 billion years, and it'll keep burning like this for another 4 billion years. There are stars that are bigger than our sun and they have higher temperatures. They burn faster and only last millions of years only. But yeah, they do burn much faster. I think that's the main. This one's the key question for the day. It takes a bit of reading with this one to work out the order of these 6 into in order. There's some clues in the ordering, and so this one says all the helium is fused. I reckon that before that there's going to be something about helium, and so like this one talks about helium fusion, this one talks about helium gets hot enough to fuse, so I reckon like this is where we're going to start. Helium gets hot enough to fuse, forming carbon and oxygen. Oh, I've given you one. That's the first one. Let's see if you can work out the rest. So next section is what happens to large stars. And so they sort of break them up into groups depending on how many times bigger than our sun the stars are. And yeah, exactly what happens to them depends on their size. 8 to 20 times become neutron stars, and more than 20 times more bigger than our sun can leave behind a black hole. And so there's another task about that too. Yep. And I think they're this is my good challenge question, this one. Anyway, don't want to talk too long. Good luck with it. I'll see you guys hopefully, if this lockdown finishes, on Friday. Good luck.